Welcome to a lesson with Dr. Powell. We're going to continue the example of computing this centroid of following shapes. So we've already computed x bar, and now we're going to compute y bar. Okay, x bar comma y bar. So how are we going to compute y bar in this case, in this shape? Remember what y is. Y is equal to this function here. So this goes from 0 to 2, this goes from 0 to 1. Well, technically speaking, we could kind of reverse our viewpoint if we wanted to, and we could think about an increasing mass variable going up this way, and we could do the exact same analysis that we did for x, although we'd have to think about now a function in terms of y, so we'd have to kind of rewrite this and rearrange it a little bit. But that is possible, and you will get the right result. But there's another way where we can use the same setup that we have for x and don't have to switch variables around too much. So there's another way of doing this, and that is, as mentioned in one of the videos, that we can look for the average value of this y mid variable as a function of m, where if m is the amount of mass up until a particular x value, then what is, and then we can actually kind of think about, so let's erase this and just kind of think about this generally. Okay, so if we have mass up until a particular point, then y mid is simply the middle y value on this line in the shape from top to from bottom to top at a particular x value, all determined by this amount of mass here. So y mid of m, that's what we want to find the average value of. So we can write down what this is, what y mid is, in terms of x. If we change variable from m to x, we can actually rewrite this as a function of x itself. Notice when we're finding the average value of x, we had x of m, and in the replacement, if we change the variable to x, this just becomes x. Well, in the replacement, this won't be x and it won't be y, but it will be, it'll be y over 2 actually. It'll be this as a function of x divided by 2. It'll be the average. In general, if you had a function down here and a function down here, you just add the two different y values and divide by 2 to find the average in the middle of those two y values, top and bottom. But one of the y values here will be 0. Makes it nice. So 0 plus the top divided by 2. So it's just that. Okay. So this is a function of m. You could also, technically speaking, write it this way: 1 minus as a function of m, if you wanted to, over 2 squared, all divided by 2, right? So that's like the middle one in the middle. So this is the function of m that we're going to be finding the average value of. Okay. So to find the average value of it, what do? We take we take 1 over the total mass minus 0. This is just the from 0 to m, and then we have our y mid function as a function of m, which is 1 minus x of m over 2, quantity squared, all over 2, and dm. So this is quite literally how we find y bar as the average value of this function with respect to a variable m. Of course, we're going to change variables now. So as before, and you can look back at the previous video, when we change variable to x, this just simply becomes x, right? Okay, because we rewrote this in terms of x, and then we could just switch it out to x there. And then dm will be the same thing as we had before, which is just the value of the function itself times dx. Why was that? Let's recall, because this is not always the case necessarily. It's whatever the shape may be. The shape might be bordered not by something on the x-axis. it could be some wobbly shape. So you have to keep this in mind. You draw a rectangle and then you actually compute the area of that rectangle using the bottom y value and the top y value. The bottom y value here is 0. We just need the height of this rectangle. The height here is given by this directly. And then you multiply by the width dx. So this is your dm. This is your y mid function right here. And then m is really the total area that we got from here to the end, which we computed to be pi halves. So this is just pi halves here. So this is the calculation to figure out y bar. Now in this calculation, notice this square times that square simply become this without a square root. So this square root times that square root just become 1 minus x over 2 quantity squared without any square root at all. This 2 is in the denominator, just like this. If we move it into the denominator over here, imagine like a 2 over 1 right here, so that it actually cancels with this 2 right here, which is nice. So we just have a 1 over pi, really. And x is going from 0 to 2. All right. So that's 1 over pi, and we're integrating from 0 to 2. We haven't integrated yet. We're just multiplying that out. Now we can compute the integral, and we'll do it over here. So we have 1 over pi, keep that constant multiplied. In the integration, we have x minus, and so this is really x squared over 4. So let's write it that way right here, x squared over 4. Okay, so that would become minus x cubed over 12. And then we're going from 0 to 2. So it's 0 to 0, so just basically plugging in 2. We get 2 minus 8 twelfths. 8 twelfths is the same as 2 thirds. 2 thirds. So 2 minus 2 thirds, which is the same as 4 thirds. So this is going to be 4 over 3 pi. So 4 over 3 pi is actually equal to y bar. So y bar is equal to 4 over 3 pi, which should make sense from our calculation for x bar, because this is just a part of an ellipse, or kind of a circle that's been stretched to this way, but still the same this way. So everything's stretched in this direction, including the x bar. So the x bar we got was 8 over 3 pi, so it should make sense that this one would be 4 over 3 pi going this way to kind of check our work. So we have just computed x bar and y bar. Y bar is 4 over 3 pi, and x bar we computed in a previous video, which was 8 over 3 pi. So we have our coordinates of our centroids. So if mass was evenly distributed, this would be the coordinates that you would want to exactly put your finger so that it would evenly balance everything and holding it in air. Thanks for watching.